Good day everyone. We will discuss about cluster index seek and index seek in this video. Let's get started. I'm going to use a database called JBS Wiki for this demo. I'm going to drop a table called table 7 and then going to recreate it. If you look at table 7, column 1 is a primary key and it is an identity column. Column 2 and column 3 is integer. Column 4 and column 5 is varchar max. I'm going to insert 1000 rows just to have some data on table 7 for this particular demo. So let me execute that. Let me switch off the execution plan. And then let me execute the insert command. It's going to insert 1000 rows. So now what I'm going to do is I'm going to turn on the statistics IO, which will basically tell us how much IO is performed on the tables as well as the queries that are going to be executed. So let me turn on. And what I'm going to do is I'm going to execute this query. This query is basically going to output column 1, 2, and column 3 from table 7. And the predicate is basically it is going to check for any rows that is between 1 and 999. So let me execute that. Let me enable the execution plan also. So now if I look at the execution plan, what I'm able to see is I'm able to see in cluster index seek. And what I'm able to see is it is estimating close to 999 rows, and it is also returning 999 rows, which is shown in estimated number of rows and actual number of rows. So both are 999. So if I look at the statistics details that we have enabled, what I'm able to see is I have performed close to 1005 logical reads. So let me copy that. And then let me put it here. Moving on, what I'm going to do is I'm going to create an index. Basically, what I'm doing is I'm creating an index on column 1 and then including column 2 and column 3. So if you see here, we have already a primary key on column 1, which is in turn going to create a cluster index. And what will happen is now any query that is going to use this cluster index will have to read all the rows starting from column 1 to column 5. Even though some of the rows are not required, it will have to read through everything if you use the cluster index. So in this query, what I'm basically doing is I'm just looking at I'm just trying to output only column 1, column 2, and column 3, and the predicate is on column 1. But column 4 and 5 is in no way related for this query. I don't need those columns to be read. But for this particular query, since I'm using cluster index seek, what is happening is it is basically reading through all the rows. Now what I'm doing is I'm creating a non-cluster index on column 1, even though I know there is a cluster index already on column 1, but still I'm creating a non-cluster index on column 1, and I'm trying to cover this particular query by including column 2 and column 3. We know column 1 is basically the cluster index. So the index, the non-cluster index leaf pages will be the cluster index. So it will be utilizing column 1 directly from the cluster index. But what I'm doing here is I'm basically covering this particular query. So let me create this index. What I'll do now is I'll run the same query. So previously, when this query utilized the cluster index, it performed close to 1005 logical reads. Let's look at this time what it does. So looking at the execution plan, I'm looking at this execution plan, and I'm seeing an index seek happening. And what I'm seeing is the estimate seems to be okay. I'm estimating 999 rows, and then returning I'm also reading and retrieving 999 rows. So the estimate seems to be good. But if I look at the IO stats here, what I'm seeing is I'm no longer doing 1005 logical reads. I'm just doing 5 logical reads this time. So what we need to understand is cluster index seek is a good thing to perform, but the thing that you need to keep in mind is If you use the cluster index, what happens is like it will be reading everything as far as that particular table is concerned. All the rows will basically be read if you're going to use your cluster index, and that is going to balloon your logical reads. Yeah. Now let's consider this is going to be a critical query, and also like it's gonna execute multiple times. The option to reduce the logical reads would be to cover this query specifically for that particular query. Create an index, a covering index that's going to completely cover that particular query, and that way you will be able to reduce the number of logical reads. That in turn is going to reduce everything as your execution time is concerned, the CPU utilized, everything as far as that query utilization is concerned, everything will be reduced. Let me drop the table 7 here. Thanks for watching. Have a great day. Jai Hind.